Okay, let's get started. The question number 2 of exercise 2.3. Here the question is, find the domain and range of the following real functions. Fx is equal to minus modulus of x. Number 2, fx is equal to root over 9 minus x square. Here, what does this real function mean? So real functions are those functions whose domain and codomain, remember domain and codomain, are set of real numbers. Then say f r to r is a real function, or domain is subset of r, or codomain is also subset of r. Then this kind of functions are called real functions. Say f a to b, is it a real function? Then we must check whether this is subset of real number, whether this is subset of real number or not. A and b must be subset of real number, then this function is real function. So I think now you understood what real functions mean. Okay, so this is a real function. It means domain is a subset of real number, or range is also a subset of real number, maybe real number or subset of real number. So which one? Let us see. Okay, so answer here, fx is equal to minus of x is defined for all real numbers. Therefore, domain of f to this way we can represent domain of f, which is R, set of real numbers, you can write. Okay. So how do I know that this function is defined for all real numbers? Yes. 1, fx is undefined if denominator is 0. And number 2, real function fx is undefined. Remember, I am talking about real function. Fx is undefined if any expression under root is negative. In these two cases, a real function can be undefined. Now, our function fx is equal to minus modulus of x is defined for all real numbers, because in this function we do not have any option like this. There is the denominator is 1 and then no root is there. These two options do not arise in this question. So directly we can say this function is defined for all real numbers, hence domain is set of real numbers. Okay, now let us see the range of this function. Actually, what is range of a function? Range of a function is the set of values of fx obtained as an output for every value of x, which is input of the function. Since we already knew that x is a real number, that is x belongs to set of real numbers, which implies mod of x, it becomes now positive quantity, means greater than equal to 0. Yeah, now it will be a negative quantity. So this must be less than 0 or equal to 0, because equal sign is there. So this is actually our function, which implies f of x less than equal to 0. So this is a number which is negative quantity. So therefore values of f, the set of values of fx, x belongs to minus infinity to 0. Range of the function is this, minus infinity to 0. So therefore domain of this function is set of real numbers and the range of f is minus infinity to 0. So this is your actual answer of this function. Okay, here for this function 9 minus x square must be a positive quantity, otherwise under root if we get a negative number then this will be undefined, as we are considering real functions, is not it? This will be a real number only if 9 minus x square is a positive quantity. Therefore fx is defined if 9 minus x square is a positive quantity greater than equal to 0, which implies minus x square minus 9 is greater than equal to 0. Now x square minus 9 less than equal to 0. What happened here? This minus is removed. Minus 3 is less than 0, is not it? Now if we remove this, then it will be a positive quantity. In that case the order sign will get reversed, isn't it? So similarly this is greater than 0. Now this minus is removed, then it will be a negative quantity. So it is less than equal to 0. Now solving this we get, see, x square minus 9, x square minus 3 square less than equal to 0. Factorizing we will get x plus 3 and x minus 3, which is less than equal to 0. So we know how to solve this by wavy curve method. For this we will get minus 3, for this we will get 3. Now if we put here positive, then this will be negative, then this will be positive, isn't it? Now this expression is less than equal to 0, so minus 3 to 3 is our required interval. So therefore x lies between minus 3 to 3 is the solution of this inequalities, isn't it? Therefore domain of fx is equal to minus 3 to 3. Got it? Now we are going to find range of this function, means values of the function fx. So for that, this is the way, let y is equal to, instead of fx you just consider y, and function is 9 minus x square, squaring both sides, 9 minus x square. Now what is to be done? X squared 9 minus y squared, then this expression is expressed in terms of y. So this is the procedure, isn't it? So we have to put here plus minus. Now you see, this should be a number in between minus 3 to 3, as x is in between minus 3 to 3. So this must be a real number. So for that, 9 minus y square must be a positive quantity. Otherwise, if it becomes a negative one, then this will be an undefined in this case, as we are considering only real functions, is not it? So therefore 9 minus y square is greater than equal to 0. It implies y lies between 3 to minus 3, just like this. Here 9 minus x square is greater than equal to 0 implies minus 3x less than equal to 3, isn't it? Now in this case, instead of x we are having y, so y is lying between minus 3 to 3, isn't it? But y is a positive quantity, isn't it? Therefore y belongs to 0 to 3. That is, actually fx belongs to 0 to 3, isn't it? Hence range of fx is equal to 0 to 3. So this is the answer of this question. Okay, thank you.